Okay, I'm sharing my screen. Okay, now I'll just change this into the SDF's directory 10th Feb. Okay, so we saw that data is earlier we loaded into this directory, our the order data into the SDF's directory. We are trying to load back import. So generally, what happens we load into SDFS or Hive and we do process, and the reports data we may load into the RDBMS for the visualization team to take it. For simplicity's sake, I'm just loading the same raw data to the order table. So this is where. So this is going to be my export directory. I'm going to export from this and see this. This is going to be changed. So instead of earlier Sqoop import you are doing, now export command you have to use. And again, we have to provide the JDBC URL, username, password, and export directory, from which directory you are going to pick the data, and what is your um, the table name in the MySQL side, and you need to provide this update mode equal to allow insert. Now let's run this, and if you look at the MySQL, this is I. Okay, the export table, I don't have any data. Let's run this and export this data. So people who are actually migrating from traditional data warehouse system to the Hadoop based data warehouse or data lake, those type of projects you will be using Sqoop. Okay, so if you get an opportunity to work on those type of projects, then definitely there will be a task on Sqoop to do the data load, one-time load or incremental load based on the requirement in your project. So this tool is going to be handy for those type of scenarios. Okay, so with this, probably I will uh, wind up on the Sqoop side, and we'll focus on now. Next, there is another component called Apache Flume. It's also a simple tool as well as a good tool to bring some of the data from outside world to the Hadoop system. We were using Apache Sqoop for the bringing a relational data to the Sqoop, and apart other types of data, we can use Apache Flume to bring the data. So we'll just discuss in short. Okay, so this load is completed. Okay, this is in. Okay, so in that HDFS directory, I was having only 7 rows, and this got loaded into this table. Okay, so this is how we can do the Sqoop export. Okay, please practice these Sqoop commands. Okay, just to get familiarized. Okay, now we'll go back to the next component, which is Apache Flume. Okay, what this Apache Flume says. Flume is a distributed, reliable, and available service for efficiently collecting, aggregating, and moving large amount of log data, right? Initially, when Flume was introduced, it was to bring your log data from different web server or it in um, uh, database server logs, and there are many logs to bring those logs into Hadoop system. Okay, so it can be a HDFS or in um, other Hadoop components. Okay, and later it supports different data, not only the web server logs and also other types of data as well, which we'll discuss now. And it is a simple and flexible architecture based on streaming data flows. So it's a little closer to the streaming data flows. So when we saw Sqoop, right? Sqoop is basically a kind of import export based on the batch. So you just because it uses the map only jobs. So we ran the command and it's going to launch a map reduce job and bring the rows into the table. But Flume, uh, say example, you want to bringing data from the logs. So whenever the new logs comes to that example, if you are reading from log file, so whenever the new logs gets appended to that log file, immediately that will be picked and sent to the target. So that's why they're saying it is a this architecture is a streaming data flow architecture. Okay, and it is robust and fault tolerance with tunable reliability mechanism and many failover and recovery mechanism. Uh, okay, that's fine. Now, okay, so when you look at the Flume, okay, so in Flume there is something called agent. Okay, so what is agent is um, basically it's a way you define your data flow. Okay, so in a agent, okay, so you have source and channel. Means when you define a agent, you define a source and channel and sink. Okay, so we'll go in detail what is source, what is channel, what is sink. Okay, so meanwhile I'll open one more. I have one more PDF. Okay, this one. Is text is visible or you want me to increase the font?
It's visible, Pari. It's
Oh,
good.
okay. Yeah, thanks for that. Okay, so we saw this is the architecture, right? Uh, what is a Flume agent? Okay, or agent. Flume agent is a process that was it's a JVM process that hosts the components that allows events to flow from external source to the external destination. So basically, it's a kind of process which is going to generate events. Okay, so when I say events, so whenever there is a new data comes into the external source, and it is going to pick that data as a event, and the event will flow uh, from source to the destination via channel. There is a channel. Okay, and then the event is a unit of data that flows through Flume agent. So when I say event, basically data which is we are bringing from this external source. Okay, so event flows from source to channel and sink. You can simply think of as a source is a kind of set of connectors. It loves set of connectors. Say example, if you want to pick it from uh, uh, log server, I'll just go and specify my log file from which the data will be picked. So it will have a set of already existing modules. So you pick it. So based on different modules it has, you need to configure. So I'll just Go to this. Where is the insert? Go to documentation. User Flume user guide. Okay, there are set of sources available. Okay, so it can be a Favre source or thrift source, exe source, JMS source. Okay, so and it can read from Kafka source. Basically, Kafka is a messaging system from which we can bring the data to the Hadoop system. And spooling directory. Just think as say you have a Linux directory, and from there you want to whatever the files comes to that Linux directory, you want to pick it and put it into HDFS or Hive. So you can consider that as a spooling directory. Okay, even you can actually bring it from Twitter. Okay, so that also available from Twitter. Also, you can bring the data. So one example I'm going to show you is a spooling directory. Okay, so what you need to provide is basically what is the type of source. I told you, so source is a basically, you can think as a set of already predefined modules available. So you just use based on your source, you have to use that particular module from the source. Based on your external source, here you need to choose your source module and just configure those. There is no coding needed. So you need to provide what is the type of source. Is a spooling directory. If it's a spooling directory module, then what is the path I need to pick the file? So you have to specify spooled here. Apart from this, these are the two mandatory you need to give. The remaining things are optional. Um, so that's how Flume agent. So it's a configuration file. So every agent will have unique name, and you need to define your agent file, the unique name, and configure other source, channel, and sync. Okay. And Flume source actually, source consumes events having a specific format. Those events are delivered um, to the source by external source like web server. Right? And when source receives the event, it stores into a one or more channels. Okay, so here the source receives the data from the external source. Uh, then it actually, when the new data comes, it will go and put it in the channel. Okay, so channel is basically a kind of intermediate storage or a buffer. Okay, and then from the channel, it will go to sync. So sync is nothing but again set of predefined modules, uh, which will actually you can pick the um, target based on the sync available, list of syncs module available. Okay. So channel is a passive store, as I told. It's a kind of intermediate storage, passive store that holds the events until the event is consumed by the sync. So when the data comes to channel, the sync will consume it from the channel. One type of channel available in Flume is a file channel, which uses a local file system as its backing up store. The data will be, if you are using a file channel, the data will be stored on a local file system. And if you use memory channel, there is another channel called memory channel, where it actually stores data in memory. And there is sync. Okay, sync is responsible for removing event from channel and putting into the external repository like HDFS and forwarding to the source and the next hop of the flow. Okay, so it write it into the external sync, and then it actually wait for the next event to be occurred on the channel. Okay, so we'll focus on interceptor later. So if I want to define a agent, okay, so this is how the configuration is going to be. Okay, so I will create a file called Flume agent 1.cnf, okay, conf, okay. I will show this in text pad. Close this. Yes. Okay, so I'll be creating this file name as flume agent spoolder.conf. Okay, and what I'm going to place is, okay, these are the commands. Okay. How do you run? I'm going to put it here. Okay, so first you need to define a agent. Okay, so this is just name, unique name you give it. Okay, and then you need to specify what is your source. Okay, my agent dot sources is a, this is also you can give any name. Okay, so I'm just given spool der underscore source name. This name can be anything. And for I'm just telling my agent that my source name is that source name which I defined is a spool der underscore source. And I am telling my agent saying my channel is a mem channel, memory channel. This name also can be anything. And sync, I just given sdfs underscore sync, which means I'm going to write I'm going to read a data from Linux directory, and I'm going to write it into the sdfs. So I told my agent that what is my source name, channel name, sync name. Now you go on to configure all these three items. Okay, so when it comes to source, so you need to, I told you, you need to provide these two properties, mandatory property. So what I'm saying is agent dot sources dot my source name and a type equal to spool der, and I have to give the Linux directory. So I'm just giving this directory as a spooling directory, so that the Flume agent will look for this directory, and if any files come to this directory, it is going to pick, okay, as a Flume event. Okay, then next I need to define about the memory channel. So again, agent dot channels dot the channel name dot type equal to unit type. Whether you are using a file channel or memory channel, I would say the type. And this is capacity. So capacity basically how many events, I guess. Just check it here. Memory channel. Maximum number of events stored on the channel. Okay, so how many events you want to store it on your channel? So 1,000 events the channel can handle. That's what I'm defining it here. So we defined the source, and as spooling directory, and the channel as memory channel, and let's define a sync. So which means that I'm going to write the data into SDFS. So again, the agent dot sync dot the sync name and the type equal to SDFS, and you have to specify the path, right, from SDFS out there. So this is the SDFS location I'm going to write. Just put this because one was I was using already. And then okay, so and the file type is data stream, and what is the file format you want to use? Text format. And there are other properties which we define for sync. Okay, so I'm just defining this, and the file when it stored on HDFS, what is my file name will be, and whether I'm going to have any suffix in my file, the output file. I'm just defining that. And finally, you need to link from source to the channel, because we defined source and channel and sink. Now we need to just link this as per this diagram. So we defined a agent, and we said agent, I have a source and channel and sink. Now we need to link this, so that the linking part is we are doing it here. So agent dot sources, which is a spooling directory source, dot channel equal to mem channel, and similarly we are connecting channel to the sink, which is agent dot sinks dot hdfs sink dot channel equal to mem channel. So this is the Flume agent definition. Okay. So based on this configuration, Flume is going to run this agent and just start looking for the new data and write it. Whenever the new data comes, is going to write into the HDFS. So it is going to, as it mentioned in the documentation, it's going to work on the streaming fashion. Okay. Okay. So installing. Okay, installing Flume is somewhere. Installing Flume is a simple step. I did not document. Basically, what you need to do is go to the flume.apache.org and go to the download and click on this binary. Okay, this one, and download this file. Okay, once you download it, so I'll just put it in the software directory, which is my Apache-Flume 1.9.0 bin.tar.gz, and extract this, then you will get this directory. Okay, then you set it on the bash RC. Just nothing, no config in anything. You just download the binary and extract it, and you set the Flume home directory, so which will be in your .bash rc file. Just set the Flume home environment variable, like export a Flume home equal to the path, and add it to the path variable, path equal to dollar path colon Flume home slash bin. Okay. So there is a command called Flume ng, which will take the Flume agent configuration and run your Flume agent. Okay, so let me create this. So either you can go and put your Flume configuration, agent configuration in Flume config, or you can have it anywhere. And when you run a Flume agent, you have to specify that Flume agent configuration. So let me create it in my home directory. So this is software. We will just create a directory called mkdir Flume agents. Okay, Flume agents. Okay, now I'll create this file. Copy this content. Okay. So when I run this Flume command, so Flume ng, probably you can, if you want, you can just check help. So these are the options available in the Flume ng command. So you can check the version. So we are using Flume 1.9.0. Agent, mainly the agent, and it has some Avro client related things. So these are the things we use mostly. Okay. So let me run this Flume agent. So Flume ng agent, and you have to provide the name of the agent and then a configuration of your agent. So this is the one. I'll just go and run it here. I'll open one more tab. Okay, so this now started. Now I'll just go and put some data into my the spooling directory, which is this. Okay, there are some files I kept there. Okay, so I'll create a test flume underscore one.txt. Hello flume spool dr to htfs. Okay, I'll copy this file into the directory. Now the once you start place this directory, it is going to pick this here file. So as it is going to generate a events, and the events will be placed on channel, and it will be consumed by the sync. So it will go and write into the HDFS directory. Now this is the HDFS directory, data flume and flume agent one underscore data slash two. This is the place I'm given for a HDFS sync location. Now let's go and check it here. I'm sorry. So this is, I think, completed. So it says we we told actually the prefix, suffix of your uh, target file is .done. So once you see this file, you can go and check this. See, this data is done here. So if I try to place one more file, what I'll do is click on one, two. I'll keep this file. Now it will pick this file. So every time there is a new files which is placed on this pooling directory, the agent is going to pick it, and then it is going to write into the sync. So this is how the Flume agent works. Um, do you have any question? Okay, any question on this Flume? Okay, I assume there is no question. Okay, so it is written the second file also. So go here. Also it's not refreshed. Okay, checking second file. And so similarly, it's going to be run. So this is going to be a long running job. So you need to keep it. You can run it this on as a background process also, so that it will be running forever. Okay, so now there are other concepts in Flume. Okay, let me. So please try. I'll share this Flume agent, and also you can just keep trying other sources. Okay, and so you can actually define multiple channel. Okay, so you can actually connect one agent to the other, right? That also we can just do using different agent and pass the informations. Okay. Okay, there's a file channel. So if you look at the sync, there is Ive sync is available, and there is HBase sync is available, and Kafka sync is available, right? And also we can write our own custom source and custom syncs. That is also possible by the uh, Flume. Okay. Now we'll go back to the other concepts. Like we saw what is agent. It's a process which is a combination of source and channel and sync. And apart from this, there is a, concept of interceptor. What is interceptor is basically an interceptor can modify or drop events based on any criteria. Okay, so you can actually kind of apply a filter whether to allow this event to be sent to the sync. Okay, so interceptor and Flume are those who have a capability to modify and drop events in flight. Okay, so that is interceptor. And the channel selector, there's another concept called a channel selector used to determine which channel we should pick to transfer the data in case of multiple channels. Okay, so if you have multiple channels, we can actually choose using the channel selector, we can choose whichever we want to pick it. And then there is another concept called a sync processor. Sync process is a mechanism by which you can create a failover task and load balancing. Okay, so basically, if there is a scenario of uh, this task is getting failed, how do you make a failover things we can do using the sync processor and also load balancing. Okay, so to invoke a particular sync from the selected group of sync, and we generally use sync processor. And another concept is event serializer. Basically, what happens is whenever we see data, right? So basically, event serialization mechanism by which event flow is converted into another format for output. By default, text serializer used. Okay, so if you take event is basically our data which is coming, right? So we just generally take event body. You can also take the header also. Um, That is also possible. Okay. See, these are the other few concepts in Flume. Okay. Um, Probably with this we will be closing this our um, um, so Flume part. Okay. I will cover. There is one more component called Kafka. Okay, that will be I will cover Kafka um, while we are going through the Spark. When we start learning PySpark, we'll do the integration with the Flume. Sorry, Kafka. So that time actually I will also I have one more few more agents which I build using Kafka. I will actually explain you about that. So because the structure is same, the Flume configuration structure is same. You need to configure source, channel, and sync. So basically, this the different properties going to be uh, different based on your what type of source, external source you are going to use it, or what type of external sync which you are going to use it. So I define for Kafka source and sync. I will actually demonstrate this once I cover the Kafka topic. Okay. So for Flume, basics and other stuff, this is should be good enough to try other example. You just keep you try for other source. Just let me know if you have any doubt. I will help you out. And next component which I'm going to focus is Apache Uzi. Okay, so tomorrow we'll focus on Apache Uzi. Okay, which is a scheduler. It's a workflow management tool. Okay, so it's a workflow uh, management tool, or it's a workflow scheduling or system to manage Hadoop jobs. Okay, so if you look at the So now what we just learned till now, we learned about SDFS, storage component, and MapReduce is a processing component. We learned about Hive, okay, so which is SQL interface for your uh, SDFS data, and we learned about Sqoop for import export, and we learned Flume, which is like again the it's a um, data uh, like tool which actually brings the data from external sources to the Hadoop, okay, in a streaming fashion, okay. Now, say example, we have a, set of Sqoop commands. It can be either import or export, or you have Hive queries, or you have MapReduce job. Okay, so how do you schedule? Whatever we till now we saw, we just take few sample and we run it and check it. So when it comes to real time, we have to schedule it, right? So we need a scheduler, right? We can use a cron tab, which is a default scheduler comes in the any Linux platform, but it's not so sophisticated or does not have any features for rerun or uh, uh, no, sending the notification when the job is done. So, but for that purpose, actually, Uzi is introduced, which has you can define a retry mechanism and notification and stuff. So we'll focus on tomorrow. Okay, next 2 days we'll be focusing on Uzi because it's a uh, uh, very important component to know everybody. Okay, so I think only 1 minute left. We can close off and we'll sync up tomorrow. Thank you, friends.